All right, now question 6a, part 3. This is a 1-mark question. So the question asks us to show that the minimum distance occurs while P1 is ascending only if V is greater than the square root of AG cos theta over 2 sine theta outside of 1 minus sine theta. Okay, so the first part about this question is you need to know what P1 ascending means. Okay, so when we think about ascending, we mean height. So in this term, when we refer to our diagram provided on your paper, P1 is going upwards. So that means its y value is increasing. So when we talk about y value increasing, we think about its rate of change, which obviously means its derivative. Okay? So what we mean by that is dy over dt has to be greater than 0. For its rate of change to be positive, it means y is increasing, thus the particle is ascending. So from your paper, you've also been given the equation of motion for this particle. So we've got y is equal to vt sine theta minus half of gt squared. So we now know what dy dt actually is. So when we differentiate this, we're going to get v sine theta minus gt as we're differentiating with respect to time. And now for that to be greater than 0, we now just have to deal with if v sine theta minus gt is greater than 0. Or for a more approachable way of doing it, if v sine theta is greater than gt. Okay, so we're almost there, but we don't have t in what we're required to prove. So we need to know how we can change t into something more usable. Well, from our second part of the question, we learnt that the minimum L occurs when t is in fact equal to a cos theta over 2v 1 minus sine theta. So all we have to do now is substitute that in to what we just did. So now we've got a cos theta over 2v 1 minus sine theta. Okay, so now to get this a bit more, we know that v and v, so I can multiply v over here, and we don't have to change the sign because we know that v is always greater than 0. So I'll take the v out from here and turn that into a v squared. And for the same reason, I'll divide everything by sine theta because we know that theta is between 0 and pi on 2. So sine will also be positive for this domain. So I'll take sine out from here. And I'm going to put sine down here. All right, so making this a bit more nice. So that will be equal to ag cos theta all over 2v, oh, not v, 2 sine theta outside of 1 minus sine theta. So if I square root everything, I'm going to get v is greater than the square root of ag cos theta over 2 sine theta 1 minus sine theta. And yes, you can argue that v has to be greater than 0. You can prove that. But for time's sake, you can say it's plus or minus, but don't worry about that because we just showed that v is greater than 0 always. So that's pretty much how you do that question.